So let's take a look at finding areas of triangles. So first, let's go ahead and revisit our area formula for parallelograms. Okay, now I've got here a picture of a square because a square is actually a type of parallelogram. So we know that the area of any parallelogram is equal to the base times the height, right? So if I wanted to find the area of this square, we would have, let's say this is 5 and 5. We would know that the area would be equal to the base, 5, times the height, 5, which would be 25 square feet. Now, if we're looking at this triangle here, right, this triangle also has a base of 5 and a height of 5. But we can tell that finding the area using this parallelogram formula of area equals base times height would not work here because we would find an area of 25 square feet, and we can tell simply looking at this triangle that it does not have the same area of the square. And in fact, it's actually half the size of this square. If we were to take this identical triangle here, which I've rotated around, if we were to take that, we could line it up. Now, I didn't make it exactly the right size, but we can see, right, that 2 of these triangles would make this square. So in other words, right, this triangle has exactly half of the area of the square. So a formula that we could use to find the area of a triangle is just 1/2 of the base times the height, right? Because if we know that this square here has an area of 25 square feet and that this triangle has half of that area, then it's just going to be 1/2 of your base times your height. So we can, again, substitute these values. So the area equals 1/2 times the base times the height. Okay, now we know with the commutative property of multiplication that you can multiply these in any order. So if you wanted to multiply 5 times 5 and find 1/2 of 25, you can do that. If you wanted to multiply 1/2 times 5 and then multiply 2.5 times 5, you can do that too. Either will work. We are just multiplying these 3 numbers. So I'm going to go ahead and do 5 times 5 first. So I know that the area will be 1/2 of 25. And I know that half of 25 is 12.5. So our area for this triangle would be 12.5 square feet. So let's look at a few more examples. So here we have a triangle on the left that has a base of 5 inches and a height of 8 inches. Again, the same thing will apply. The height is going to be based on what is perpendicular to the base. So again, we can see from our vertex here, we go perpendicular, 90-degree angle to the base here. So our base is 5 and our height is 8. So the area will be equal to 1/2 of the base times the height. Okay, so in this case, right, we could go ahead and multiply. And again, this time I'm going to do 1/2 and then 5 times 8, which is 40. And I know that 1/2 of 40 would be 20. So my area for this triangle would be 20 square inches. Okay, and as we look over here at this obtuse triangle, okay, you'll notice, right, that my height is shown outside of the triangle with this dotted line. Okay, and that's simply because we always want to go from this opposite vertex here. So again, I want to go from a vertex because if I were to start here, I'm not going to find the height of my triangle. So we always go from this opposite vertex, right? That's where these sides meet. And then we'll go perpendicular again to our base. And that is 9 meters. And once again, on Big Ideas, they will provide these measurements to you. They will tell you, like this does, that the height is 9 meters and the base is 12. So again, we'll use our area formula for triangles, 1/2 of the base times the height. So this time we have 1/2 of 9 times 12. Okay, and this time, again, I'm always choosing when I do these, if I'm solving mentally, I always choose to work with the easiest numbers. So for example, in this case, I know that 1/2 times 12 is 6. So I could rewrite this as the area is equal to 6 times 9. So my area here would be 54 square meters. And just to show you again that any order would work, you could do 1/2 of 9 times 12 and first do 9 times 12. You would get 108, and then you could find 1/2 of 108, which again is 54. So just showing you the commutative property of multiplication. The order that we choose to multiply does not matter. Now let's look at finding a missing side or a missing dimension. So this time we're given the area and we're given the height. You can see our height is 12 millimeters, and we want to find the base. So again, we'll use our area formula. The area is equal to 1/2 of the base times the height. So this time we'll substitute the values that we're given. So we're given our area, which is 56 square millimeters, and we're given our height, which is 12. So we have 1/2 times b times 12. Okay, and again, I could multiply 1/2 and 12, and I would get 56 is equal to 6 times b. And I want to isolate b because I want to know what my base is. So I can divide by 6 on both sides to solve for b. So b will be equal to 56 divided by 6. We would get 9 2/6, which we could simplify to 9 1/3 millimeters.